So, yeah, talk is recording. I will cut it. So,
okay.
Giving a warm welcome for Chris.
Okay, so hi everyone. It's really nice to be here in Berlin. Today I would like to make everyone experience with RxJS a little bit better by using custom operators. So just one slide about me, no worries. I'm Chris Trześniewski. Don't worry if you can't pronounce that name. I'm a developer advocate and senior front-end developer at Scalac. I will post this link later on my Twitter. And let's get started. So just to have a little bit of an introduction, I hope everyone knows what an observable is, but just to have it all covered. So it's basically a stream. If anybody of you used to work with promises, when switching to RxJS, it feels like it's like a promise on steroids. But it's both much more than that, and it's a really simple concept, because it's basically a function that ties an observer to a producer of data. But the way I like to think of it is that it's basically data delivered over time. So it's like an array of data, but the data come to this array over time. So this is a way to visualize that. And what are operators? So I like this quote: operators are the things that you put in front of your stream before getting the values out of it, and quoting Ryan Chenky. So how we can visualize that? Because I'm a really coffee snob, so I like to show this example. So we've got let's imagine that we've got a stream of coffee beans coming out of the farm, and we want to get our drink. So to accomplish that, we need to put many steps in between the input stream and our output stream, and you can think of that as a stream of piped operators. So we've got plenty of them already built in with RxJS. So we've got some filtering ones, like filter, debounce, throttle. We've got also some transformation operators. So the most basic ones are map, scan, and reduce. In RxJS world, we have to distinguish between reduce and scan over time. We have switch map, merge map, and all kinds of maps there. And we also have some combining operators, which are really useful, like combine latest with latest from, zip, and so on and so forth. Basically, how we use them is we get our input stream, and we want to filter our data. So we put a filter operator, and we only get the values out that with the remnant of division by 3 is equal to 1. And we can chain the operators. That's the cool thing of RxJS. So we can put another operator right afterwards and multiply it, for example, by 7. And this is how the code looks like. I'm pretty sure most of you are familiar with this, how it's written in code. So we have our source observable. We use the pipe function to chain our operators, and then we just put them in. We can put as many operators as we want to and chain them together. So there's actually over 100 operators. As far as I remember, there was 105, but maybe there's more now. As RxJS 7 is out. I'm not sure if it's out already, but it's gonna be out. So do we even need a custom ones? Well, if we didn't, there would be no use for this talk. So yes, we do, at least from my perspective. So how can we benefit by using custom operators. So we can create some basic specific operators based on the existing ones. So I will show the examples in a moment. We can extract multiple operators into one more meaningful and reusable piece of code. And if there's something that we really can't find in the existing operators, which we could chain together, we could create missing pieces ourselves. So let's start with the most simple examples. So what actually are operators under the hood? Because this will help us build them on our own. So under the hood is basically a function. Again, it's taking an observable as an argument, and it's returning another observable. It might be of a different type. So this is basically a signature in TypeScript of an operator function. And to show you the most simple example I could think of, identity function is already an operator, which does basically nothing, but it is. So how do we put that in real life? So we can extract the most common use cases as to a more meaningful name. So for example, we can create operators like not null, is truthy, which are basically filtering values, but we don't have to put the predicate every time we want to use them. So we just use not null, we assign filter with the appropriate predicate, and we can reuse it all over our code. The same goes to is truthy. Yeah, but that's simple. We can also have parameterized operators like multiply and power, which take advantage of the map operator. So we can create multiply by passing our m multiplier value and use it across our code base as well. Same goes for power, so we can take our values from our input stream to the power of p. Okay, so that was the really simple example. Maybe some of you were using that already. The next really useful example of using them is by to group multiple operators into one. So this is something that I've used a lot in my past projects. So so the basic idea is that we have a function that takes a source, and then we pipe our operators whichever we want to, and then we can use my operator as all of them chained together. So in real life, we can use the example from the picture I've shown you before. So odd values times 7. We first filter odd values, and then map it to multiply it by 7, and then those two operators can be used as one. But something more useful is when working with, for example, GraphQL. At least in Angular, it exposes API. In the API, it exposes observables. So, but it's not a raw data. It's kind of a wrapper around the data, which tells us if it's loading, if it's loaded. It can return nulls and so on and so forth. So, and we are actually most often interested in the data itself. So when it is available, we want to get it, put it into our application. So we can create an extract data operator and pipe all three operators together. Is truthy, which is the one we already actually created by ourselves. Then we check if the response is loading or not, and we filter only if we pass through if it's loaded, and then we map to the data object itself, which is the thing we are actually the thing we actually need. So we've covered two most common use cases of custom operators. But what if we need to create something from scratch? So there's no operator in those hundreds that can serve our purpose. Then we can create something from scratch. And this is basically the recipe to do that. So it's again a function that takes a source observable as an argument and creates a new observable. In this case, by using basically a raw observable constructor. So whenever we subscribe to our result observable, we will call this function, and we can subscribe to our source and do something in our next error and complete callbacks to modify our source observable and put different data into our observer. So let's start by creating something that is already existing, but to grasp the concept. So this is almost the same scaffolding, but I took the project function as an argument to the custom map, just like we do with the normal map. And in our next callback, is it working? Yeah. In our next callback, we just project the value we get with this function we get passed. And basically we get a custom map implemented by our source. It's just nothing to be scared of. What's happening? Okay. But the more common usage as it is in the code base of RxJS is by using class-based approach. So it seems more complex in the beginning, but it gives us an opportunity to, for example, convert imperative code to more reactive way of thinking. So we can, for example, take our algorithms and put it in our JS world. So first we need to create our, as we did already, a function that takes an observable and returns another observable. So to do that, we use a lift function, which basically takes an operator and which will convert our source to do something meaningful. And then we create another object of a class, which is of an interface operator. And this interface defines only a call function, which will be called whenever we subscribe to our resulting observable. So when we subscribe, we most probably want to subscribe to our source and apply our custom map subscriber. And custom map subscriber is basically a base class overriding a base class of subscriber. If we don't do anything, it will be like an identity function, but we want to do something, so we can override the next callback and use our project function to put our values into the destination. So those were examples of something that is already existing. So we created a custom map operator, but this only makes sense to create something that is doesn't exist yet in RxJS. So I came up with the operator which I called buffer delay, which we give time in milliseconds as a parameter. And then, if more values are emitted in a given time slot, for example, 1,000 milliseconds, we will space them evenly with the delay time. So if we click like hell, to our interface, the output will emit our clicks every second, and so on, until we run out of the clicks. And if we stop clicking and click after the second passes, this will be not stopped, it will be emitted right away. So how can we do that? And this is the scary part, live coding. So I've created a simple application to showcase how it's working. Those are the custom map operators which I shown you before, which basically work like that. So we map values to f dash value, and same with the class-based approach. So this is not click on. So those are the two custom map operators, but we are interested in our buffer delay. So I will show you how to do that both in the functional way and class-based approach. And let's start with the functional way. Just see that it reloads. Okay, so for now it does nothing, just passes the values through. And let's go to sandbox. As we can see, this is just the basic scaffolding of a function that does nothing. Awesome. So the way I describe this operator, we give it where's the time? Buffer. We give it time here in an argument. And this operator works like a dam. So it opens every let's say second, and if the value comes through, it closes and for 1 second for the given time. So for example, for 1 second, and after the second, it opens again. So to do so, we can create a behavior subject, which can define this behavior. Open subject, new behavior subject, and let's assume that our DAM is open by default. So we will give it true. And it's a good practice to have a separate object for putting data in and getting data out. So I use open subject as observable to get rid of all the next for the interfaces to push our data in, and then we can pipe oh my god, and filter only values that are true-free. So so now we've got an observable which tells us if the DAM is if the imaginary DAM is open. And whenever the DAM is open and our source is here, gives us a value, we want to emit this value to our observer. So to do so, we can use an operator which is already existing called zip, which basically ties emits only if both streams emitted one value, and it emits first values at the same time, second values, and third, and so on and so forth. So if we put source here and our open, and we need to import, and actually return. Let's return this. Typing is hard. Okay, so we zip those two values together, but we need to do something with that. So we use our pipe function to chain some operations together. So first of all, whenever the value comes through, we want to close the DEM. So we can use a tab operator to perform a side effect, and here open subject will be nexted with the false value. So it means that our DEM is closed. And after a given timeout, so here we want to open it again. So we can use our old friend called setTimeout. I know it's, but it's good enough. And after the given time, we push through to our subject. Okay, so we've got the opening and closing of the DEM. Now we just need to emit a value. So to do so, we are actually interested only in the source. Open observable, just we use it just as a timing for timing. So now we can map back to our source. So this is like source and open, and if we map back to source and actually import map, we can get rid of this because we don't use it. So zip will emit an array of every of the values in every of those input observables. So we are interested only in the source one, and then we need to subscribe to our and pass those values to our observer. And this is not needed anymore. And if I didn't make any mistake, it should work. Okay, so I click once, wait a second, click second time, wait a second, it's good. Then I will click 3 times, 1, 2, 3, and it's spaced evenly. And if the time passes of a second passes again, it goes through again. So if I click like crazy, our UI or something, our backend won't get flooded with requests or something like that, if we need to pass all of them to the backend, for example. And we can do similar, the same behavior using the class-based approach. So here we need to be a bit more creative, at least in this example. So I will override the next next method, just to okay. So in this function-based approach, we had an access to the source observable right away, but here we kind of lose it because we only have access to the next method, which will be called every time the value is pushed to an observable, and we need this source. So to get it back again, we can use a subject again and call it source. Source subject, new behavior subject, open all. And as we did before, source subject as observable, pipe, and I think I've got my not null, so it helps us make our code easier. And then we mostly copy and paste, yay. But instead of defining it as const, we have private properties of a class, and this. Okay, and then all this logic needs to go into the constructor. Zip source this this and it's called destination here, and we don't return anything. Okay, and we just need to next to our source subject the values we get, and this should be all. So let's go to our app component and uncomment the second operator, and keeping my fingers crossed. So I click once, it works. Second time it works. 1, 2, 3. Live coding is always scary. To summarize, we can use custom operators to create more descriptive names for our for operations we use. For common use cases, we can chain multiple operations to create one more descriptive one, and we can create our own brand new shiny custom operators from scratch. And now we know how to harness the power of operators. So, but always remember, with great power comes great responsibility. So don't overuse it. It was really hard to come up with some example of something that might be useful or might not be. I decide for you. I leave it for you to decide and test it, because on my first presentation I did a mistake and it wasn't working as expected in some edge cases. So do test it. It will be, of course, safer to put it into production. Thank you. If you have any questions, I don't know if we have time now, or you can come, hit me up during the break. That's all. Robin! Questions now or later?
Questions now. If you have any questions for this, so I need to go outside, so.
I've got one.
Yeah.
So, I mean, did you explain a little bit more about the lift operator?
About what?
Lift operator.
It works.
Can you repeat the question for the?
Okay, so the question was how the lift operator or function works.
Yeah.
It basically works almost like a pipe, but takes only one operator in. So it creates a new observable with the source one as an input and an operator as something that converts the. So it basically intercepts the source observable, applies whatever operator is doing to it, and redirects it to the destination observable. That's basically it. Is that?
What's the difference to map?
Yeah, exactly.
No, map is an operator, and lift is a function that will apply this map operator to the source observable, like a pipe.
And pipe are only single one.
Yes.
Is there any difference in using the class-based approach or the functional approach?
Is there a difference in using class-based approach and function-based approach? Well, for this example, as you could see, it was much easier to create a functional-based approach, but I can show you afterwards that I couldn't come up with the way to use a functional-based approach to a different operator. So I had to. So the class-based approach is really useful when you want to convert something, some part of your code that is written in the not reactive way to convert and use it within RxJS.
Any other questions?
Okay, thank you again.
Then thank you again.